Okay, so when it says complete dissociation, you just had to break it down. So the first substance is HCl. Because it says aqueous, that means it's an acid. Now, if you had trouble identifying if it was a strong or weak acid or base, I get that. I didn't teach you that, but I do hope that you would have been able to at least say if it was an acid or a base. So take a look at HCl. Does it have a hydrogen ion or does it have a hydroxide ion? So would you say that would make it an acid or would that make it a base? That would make it an acid. So we're going to use red for that. You didn't have to use red, but as I told you yesterday, red means acid, blue means base. So what ions does HCl break down into? What ions do you see in that compound? A hydrogen ion, which is +1, and a chloride ion, which is -1. That's it. That's it. Now, it does have hydrogen, so as you guys said, it is an acid. But to take it one step further, how can you tell if it's a strong acid or a weak acid? Here's how you can tell. If it completely dissociates, where you have like individual ions, they're all monatomic, that makes it a strong acid. So this is a strong acid. I know that because it completely dissociated. The strong means it completely dissociated. If you don't know what I mean by that, wait till I get to a weak one. You'll see what I mean. And then an acid, dissociated. And the acid part simply means it had the hydrogen ion, which is right there. So let's just do a few more. We can go through all these. I really don't mind. Sodium hydroxide, NaOH. Does it have hydrogen or hydroxide? So acid or base? It's a base. What ions compose sodium hydroxide? Sodium ion and a hydroxide ion. That's right. So you all said it's a base. Now, it did completely dissociate. When I say completely dissociate, here's what is meant by that. This right here means that it is a base. So let's put that over here. The fact that there's hydroxide means that it is a base. Take a look at that. Is sodium a monatomic ion or a polyatomic ion? It's monatomic. Monatomic means there's only one atom. This means that it is a strong base. Take a look at H2SO4. That's called sulfuric acid. Does it have hydrogen or does it have hydroxide? So is it an acid or a base? It's an acid. How many hydrogen ions are there? Now this is where you guys really need to pay attention to this part. This is going to be important. You do not write H2. That means hydrogen gas. Instead, you're going to say there are 2 hydrogen ions. And then you have SO4, which is sulfate. Now keep this in mind. Right there, what is the charge of sulfate? -2. So how many hydrogens do you need to balance that out? You need 2. That is why it is H2SO4. Now, because there's a hydrogen, it is an acid. But take a look at sulfate. Is that monatomic or polyatomic? Polyatomic. So this would make it a weak acid. KOH. Acid or base? Colby? KOH. Potassium hydroxide. It's a base. We have potassium and we have hydroxide. The fact that it is hydroxide means that it is a base. And take a look at the potassium. Is that monatomic or polyatomic? Monatomic, so does that mean strong or weak? Strong. It completely dissociated. Keep going. Here we have HC2H3O2. I'm not going to give you its name because that would give it away. Scout, does this have hydrogen or does this have hydroxide? Hydrogen. Now let's see what you guys really remember from first semester. What is the polyatomic ion that is in HC2H3O2? This is one of the 8 that I told you you had to memorize. Do you know what it is? No one remembers? That's a shame. Well, there's one hydrogen and there's acetate. That's right. So its name is acetic acid. C2H3O2 with a -1 charge. Okay, there's hydrogen, so what does that mean? It's an acid. And take a look at that acetate, C2H3O2. Did it completely break apart? Nope, so it's a weak. And also, here's another first semester strategy. What is the charge of acetate? Look at it. Negative what? 1. So how many hydrogens do you need to balance that out? 1. That's why it's only 1 hydrogen. Okay. HCN, acid or base? Max, HCN. Does it a base mean a base is going to be represented by hydroxide, Max? Does that have OH?
No.
So what does it have? H or OH?
H.
So what does that mean?
Acid.
That means an acid. Make sure I'm recording all this. Huh. It was not recording. That's strange. Why is my screen paused? Hold on a second. Okay. Sorry about that if you're watching online. For some reason, there was a little technical difficulty. We're back. HCN. Okay, so we have, how many hydrogens are there? 1. And the other ion is one you guys did not have to memorize, so I'm happy to give it to you. It is called cyanide. And let's see if we figure this out. How many hydrogens are bonded to that cyanide? So what must the charge of cyanide be? -1. Because there's hydrogen, it is an acid. But because you have cyanide, is cyanide, by the looks of it, a polyatomic ion or a monatomic ion? Polyatomic, so that makes it weak. Keep going. Jade, I know you were not here yesterday, but let's see if you're picking up on this. This is called copper 2 hydroxide. The fact that it has OH means what? It is a base. Now, notice I just said copper 2 hydroxide. So what must the charge of that copper be? +2. And how many hydroxides do we need to balance out that copper 2? We need 2 of them, so we're going to say 2OH. The fact that there is OH means that it is a base. And Jade, is copper monatomic or polyatomic? And so does that make it a strong base or a weak base? Strong. Any questions on 1 through 7? Understanding it better than you may have last night? Good. Let's keep going. Here we have ammonium hydroxide. Emma, is this an acid or a base? Base. What ions does it form?
NH4.
NH4. That is called ammonium. That is a +1 charge. And hydroxide, -1 charge. The fact that it has hydroxide means that it is a base. But take a look at ammonium. Is that a polyatomic or monatomic ion? Poly. So does this make it strong or weak? Weak. Good. Keep going. Here we have calcium hydroxide. Derek, the fact that it has hydroxide means what?
It is a base.
How many calciums are there?
There is 1.
What is the charge of that calcium?
+2.
Very good. And how many hydroxides are there?
2.
Very good. So we say 2OH. The fact that there's a hydroxide means that it is a base. And Derek, is calcium polyatomic or monatomic?
Polyatomic.
No. Poly means multiple atoms. Calcium is only 1 atom. So that's monatomic, so that means it is strong. Okay. Ooh, here's a good one. Okay, this is going to be a toughie. Here we have methyl ammonium. And we're going to skip this one because there's polyatomic ions here that you guys don't know what to do with, so we're going to skip that one. Don't worry about it. And that's it. Let me give you one more, bonus round. Acid or base? How do you know? That's hydrogen. How many hydrogens does it have? So 3H plus. And what is the other ion? What's PO4? Phosphate. What's charged phosphate? Here's a hint. You needed 3 hydrogens to balance it out. -3. The fact that there are 3 hydrogens means that this is a acid, but is phosphate polyatomic or monatomic? So what does that mean? It is a weak acid. That's the acid I told you that's in soda. It breaks down rust. It dissolved that worm I told you about. You drink that. Ugh, nasty. Okay. Again, I don't know why this. All right, guys. You will have another homework assignment tonight. So let's go to that. Yeah, if you didn't turn it in online, turn it in now. Don't worry, I'm going to be gentle when it comes to grading. You guys are new at this. Where's the Kim? What? Hurry up. Oh well. All right. So let's see what you guys may recall from yesterday. Hold on a second. All right. There we go. Let me make sure I'm sharing properly. Good. Okay. Yesterday we did 2 different models for identifying acids and bases. First, we had the Arrhenius model. According to the Arrhenius model, what makes an acid an acid? If it possesses hydrogen and releases hydrogen ions in water. What makes a base a base? What must it possess? Hydroxide. And it releases hydroxide in water. Good? Okay. That's basically it. So that's what your homework was like. What substance would this be? An acid or a base? That would be an acid. This is called nitric acid. It breaks down into 1 hydrogen ion and 1 nitrate ion. It's partially dissociated. That would be a weak acid. Now the other one. Let's do another example. What do I want to do? Okay. That is a base. You can tell because it has hydroxide. How many aluminums are there in that compound? No. 1. What must the charge of that 1 aluminum be? +3. How many hydroxides are there? 3. So you write 3 OH. You do not write OH3. 3 OHs mean you have 3 separate OH ions. Okay, and the other model that we did yesterday was called the Bronsted-Lowry model. This states that an acid is a what? Anybody recall? Anyone at all? Is it a hydrogen ion donor or a hydrogen ion acceptor? It's a hydrogen ion donor. A base is a hydrogen ion acceptor. So let's do a couple examples, and this is going to get us into conjugates today. Let's try one. Let's see. What do I want to do for example? All right, let's try this. You ready? Here's an example. Okay. This is going to be the start of what I hope is your understanding of conjugates, and this is what your homework is on tonight. Here we go. This right here, HBr, just by looking at it, you would say, oh, that's an acid. But you can't just go with that. Here's what I want you to try to think of. Here's HBr on the reactant side. What did it become on the product side? Did it become hydronium? Or did it become a bromide ion? Like, what's left of it? Well, here we have hydrogen, and here we have bromine. Over here, we have bromine all by itself, poor little guy. Did that bromide lose a hydrogen or gain a hydrogen? Okay. Another word for lost is donate. Point is, you don't have it anymore. If you lost your phone, or if you donated your phone, point is, you don't have your phone anymore. So, HBr is now just Br. Did that hydrogen get added to HBr, or did it get lost by HBr? Okay, so what does that tell you about HBr? According to the Bronsted-Lowry rules, is HBr an acid or a base? Did it gain a hydrogen or did it lose a hydrogen? Okay, so here's another way to accept it. Did it donate a hydrogen or did it accept a hydrogen? Donated. So according to the rules for Bronsted-Lowry, does that make it an acid or a base? This is an acid. So you can pretty much fill out the rest of them from here on out, guys. If that's the acid, what does that make water on the reactant side? You have to have an acid and a base when it comes to this model. So if HBr is the acid, what does that make water? That's the base. Now, HBr is now just Br. The opposite of an acid is the conjugate base. So let me please tell you this before. Or let me please tell you like this. An acid is the before form. The conjugate base is the after. So if Derek is wearing his hoodie right there, Derek is an acid. He donates his hoodie. Now it's just Derek without the hoodie. Well, check this out. Let's say that hydrogen is his hoodie. This is Derek. And now Derek is hoodieless. He is now a conjugate base. The acid and the conjugate base are like the yin and the yang. They go together. They fit together. They're the two sides of a coin. They're the same coin. They're just opposite sides. Which means that here's H2O. What did H2O become on the product side? I'm going to need your feedback here, guys. I'm glad you're thinking about it, and I hope that you're taking a moment to think. But if you don't interact with me, I can't tell if you're learning it or not. So don't be shy. What did H2O become on the product side? It became hydronium, H3O. What changed? It went from H2O to H3O. What changed over that time? It gained or accepted, whatever word you want to say. It now has a third hydrogen. So it accepted a hydrogen. So water is the base. What's the opposite of a base? The conjugate acid. Now, I want you to look at this going from right to left, okay? Let me tell you why we call these base and acids. Take a look at poor little Br right there. Does it have anything? Does it have a hydrogen? No. Does it have a hydroxide? No. Poor little guy. Well, let's look at it from right to left. What does Br now have? Did it accept a hydrogen or did it release a hydrogen or donate? It accepted. So does that make Br a base or an acid? It's a base. Now take a look at hydronium. It is H3O. What does hydronium become if you go from right to left? What did it turn into? It went from H3O to H2O. Did it gain a hydrogen or did it lose a hydrogen? It donated one. So what does that make H3O? The conjugate acid. Yes, Nicole? It can be, but you can also identify which one's which by just, if you identify what the acid is on the left, you know that whatever that acid turned into on the product side is going to be the conjugate base. Yeah, you just have to follow what's receiving a hydrogen and what is giving a hydrogen. You can only go one direction at a time. Either direction is going to be fine. The left side is always going to be acid and base. The right side is always going to be the conjugates. So take a look at this. This ball is hydrogen. You ready? Catch. What am I? I just lost my hydrogen. Max, paying attention? I'm an acid. What does that make him? Okay, now let's go in reverse. He just gave me his hydrogen. What does that make him? He's the conjugate acid. What am I? I received it. Okay. So the example I have is when a father has the ball in his hand, he's the acid. That's me. Pretend Coley's my son. I throw the ball, the hydrogen, to my son. I am the acid. He is the base. The donor is the acid. The recipient is the base. But now if you flip that, you get conjugates. So let's continue to do more examples on this. Here, throw it up. So we're just going to do plenty of examples today, guys. We're going to do acids and bases, all right? We have HF. I'm not going to say the name because it would give it away. Okay. I almost said the name. Take a look at HF. What do you think HF could be paired with on the product side? H3O or just the fluoride ion? Okay, good. What changed? It went from HF to just F. I can't say the name of HF because I'm not gonna, that would give it away again. So the F with the -1 charge is fluoride. This is fluoride. What changed? Did it lose a hydrogen or did it gain a hydrogen? It lost. So what does that tell you HF is? It is an acid. And so what does that make the fluoride ion? Bingo. And so now that you've already ascertained that that is the acid, I can tell you the name. It is called hydrofluoric acid. Okay. H2O became H3O. What changed? What happened in order for it to go from H2O to H3O? Just tell me how they're different, guys. That's all I'm asking. How are they different? Nicole? It gained an electron. Key word. It gained. It received. So what does that make H2O? It is the base. And so what does that make H3O? Conjugate acid. So if you were to go from right to left now, Jade, fluoride, let's erase this. Fluoride becomes hydrofluoric acid. Does it gain a hydrogen or does it lose a hydrogen when you go from right to left? It gains. So that makes this a base. Jade, we go from H3O to H2O. Did it gain a hydrogen or lose a hydrogen when you go from right to left? It lost, which makes that the acid. The product side are always the conjugates. The reactant side are just going to be the plain old acids and bases. Let's do another example. Hopefully this is sinking in a little. Okay, this is called ammonia. This is water. This is ammonium. And this is hydroxide. Who have I not heard from yet? Kayla. What did NH3 become on the product side? Did it become NH4 or OH? So, Kayla, what elements do you see in NH3? Do you see any oxygen? So why would you say there's oxygen?
Oh.
What changed between NH3 to NH4? Perfect word. It gained. Another what? No. Kayla, what is H? NH3 versus NH4. What changed? A what? A hydrogen. So it gained a hydrogen. The fact that it gained makes that an acceptor. Does that make NH3 the acid or the base? The base is correct. Okay, so Kayla, if NH3 is the base, what does that make NH4? Correct. Francis, you weren't whispering to her, were you? Good. Okay, so Kayla, if NH3 is the base, what does that have to make the water? The left side has to have an acid and a base. You've already gotten the base, so what must the H2O be? That's right. Whoops, wrong color. And H2O became OH. So think hard. What is the difference between H2O and H3O? How many hydrogens are there in H2O? How many hydrogens are there in OH? So did it gain a hydrogen or did it lose a hydrogen? And doesn't an acid mean that a hydrogen was lost? So there we have it. So if water is the acid, what does that make OH? That is correct. All right. Let me see if I can just look up some more examples because I think you guys really need some practice on this. So let's just look up a few. Maybe we can look at your homework tonight. Maybe do a couple. Maybe not. Let's see. Conjugate, acid, base, pairs, examples. Just wanted to get some examples in your system here. Ooh, here's a good one. All right, here we go. Okay, here we go. Let's see. John, you're up. I want you to check out this little guy. I cannot say its name because it would give it away. What did this react to become on the product side? Did it become H3O or did it become acetates? What do you think? Okay, so these two are together. So I want you to tell me, simply by their structure, simply by the elements that make them up, what is the difference between HC2H3O2 versus C2H3O2? Perfectly said. It loses a hydrogen. What do we call something that loses a hydrogen, an acid or a base? Look, there it is. You need to get that in your heads. Hydrogen donor versus hydrogen acceptor. So tell me again. It's an acid. The name of that is called acetic acid. Okay. John, what did H2O become? On the product side, what substance? No. You're not giving me the answer I want. I have H2O. What did it become on the product side? H3O. That is correct. Arshan, please. H2O has 2 hydrogens. H3O has 3 hydrogens. Did it gain a hydrogen or did it lose a hydrogen? Okay, so what do we call something that gains a hydrogen? You're slipping. And, no, you said acid, base, acid. Let's go back up here again. What is an acid considered? A donor. What is a base considered? An acceptor. So I'm going to give you this ball. That ball is a hydrogen ion. I gave you my hydrogen. What does that make me? An acid or a base? And you accepted that ball. You accepted that hydrogen ion. What does that make you? Okay, now let's flip it. You just gave me the ball back. What does that make you? So you're the conjugate acid now because we're going in reverse. And so I accepted it. What does that make me? Okay, so let's try again. I'm giving you my hydrogen. We're going in the forward direction. What am I? We're going in the forward direction, just acid. And you are the acceptor, so you are the, and now we're going to go in the reverse direction. You just gave me the ball. What does that make you? You're saying base acid. Conjugate acid. What does that make me? One more time. We're going in the forward direction. This is my hydrogen. I gave it to you. Emma, help a brother out. It's up here. I'm the acid. Why am I the acid? And I gave it to you, so what does that make you? Okay, now we're going to go in the reverse direction. What does that make you? And what am I? You got it? Let's try it. Let's look at this. So, John, H2O becomes H3O. In order for H2O to become H3O, did it gain a hydrogen or did it lose a hydrogen? So does that make it an acid or a base? It makes it a base. Correct. Okay, now let's go in the reverse direction, all right? Let's erase these. We're going to go from here to here. John, what is the difference between C2H3O2 and HC2H3O2? You gain an acid. So what do we call something that gains an acid? Or sorry, you said gains an acid. It gains a hydrogen. What do we call that? If it gains a hydrogen? It goes to the acid, but I'm talking about this. And now because it's on the product side, what is it? It's a conjugate base. Here we have H3O become H2O. Nicole and Arshan, I know you're trying to help each other out. It's going to be on the YouTube video, but I need you to pay attention up here because while you two are talking, you're missing all this. John, we go from H3O to H2O. What changed? Okay, what do we call something that loses a hydrogen? And because it's on the product side, what do we call it? That's right. Let's try one more, then we'll move on. Ooh, here's a good one. Okay. Max, you're my victim. I mean, volunteer. Emma! Oh, there it goes. Trying to scare you. You didn't get spooked. It's no fun. All right, Maxie boy, here we go. Max, this is the reactant side. This is the product side. According to you and your powers of observation, what does it appear that CN with the -1 charge, that is called cyanide, what does it appear that it becomes on the product side? Does it become HCN or does it become OH with the -1 charge? I agree. So let's pair those up. Okay, Max, what is the difference between CN? Now, by the way, I might be talking to Max. This goes for all of you. So be answering this in your head while I direct my questions to him, but this goes for all of you. Max, what is the difference between Cn in a negative one charge and HCN?
CN doesn't have it.
So did it gain a hydrogen or did it lose a hydrogen?
It was.
So you're telling me that Cn lost a hydrogen to become HCN.
Yeah, okay.
It gained a hydrogen. What do we call something that gains a hydrogen?
A base.
Okay. Max, what does it appear that H2O became on the product side?
OH.
That is correct. Max, what is the difference between H2O and OH?
There's one more H in H2O.
Okay, so when you go from H2O to OH, was a hydrogen added or was a hydrogen lost?
Hydrogen is lost.
What do we call something that loses a hydrogen?
An acid.
That is correct. Now, Max, the opposite of a base is a conjugate acid. The opposite of an acid is a conjugate base. But I want to take it one step further. Now, here's what you all can do. Here's the cheat. But I want you to try to make sense of it. But here's the cheat first. If you can figure out what the base is, whatever the base turned into is always going to be the conjugate acid. If you had a coin, if one side of the coin said base, the other side of the coin would say conjugate acid. And if you had another coin, the top of it said acid, the opposite of that coin would say conjugate base. They're always together. But I want you to try to make sense of this. So Max is going to help us out. Max, what does OH become on the product? We're going to go from right to left, okay? So we're going to start here. We're going to go this way. What does OH become on the reactant side? Does it become H2O or does it become cyanide, CN?
H2O.
You are correct. Max, what is the difference between OH and H2O?
H2O is one more H.
Okay, so did it gain a hydrogen or did it lose a hydrogen?
Okay, that is
And what do we call something that gains a hydrogen or receives a hydrogen?
a base.
And because this is on the product side, what kind of base are we going to call it?
Conjugate.
That is right. And Max, let's keep this party going. What does HCN become on the reactant side?
CN.
How did it get to be like that? What happened to it?
It lost
And what do we call something that loses a hydrogen?
an acid.
And because this is on the product side, what kind of acid are we going to call it?
A conjugate acid.
You've got it. Well done. Does everybody get this, or should I do one more example? Marshawn?
Since it's a reversible equation, you just know that the conjugates are on the right. and
Yep.
the real ones are on the
Every
left.
time. Every time, no exceptions. Anything else? Are you guys getting it? I think that you need to, I think several of you just need to stare at that for like a good 5 minutes and let that sink in, and everything else will be cake. You need to know that hydrogen ion donors are acids, hydrogen ion acceptors are bases. Yes?
So when it comes to this and then the other one, or the unmanaged model, and then this was potassium chloride model, can they do they coexist?
No.
It's like, no, so they're completely separate.
Yep. Okay. We good? All right, let's, we have 10 minutes left, so let's get into naming. You guys should have what you need in order to do your homework tonight, but I want to take a step back and do something we did in the first semester, and that's naming. So there's two types of main acids. There's called monoprotic and polyprotic. Product means protons. A hydrogen ion is the same as a proton. How many does mono mean? One. And how many does poly mean? Many. So that's going to help you out. Mono means one. Poly means many, which is basically two or more. So, Product means proton. Remember that a proton is a positively charged ion? Keep this in mind. A hydrogen ion is equal to a proton. They are the same thing. It's a positive one charge, no electrons. It's the same thing as a proton. Okay? So, here's the deal. Set it down. If you're just walking in from FSA, be sure you watch the YouTube video because we have less than 10 minutes. If you have an acid that only has one hydrogen ion, that is called a monoprotic ion. So, monoprotic acids include HF, HCl, HNO3, HClO4, HBr. What do they all have in common? They only have one hydrogen ion. And what's the prefix for one? Mono. That's right, monoprotic. So what do you think polyprotic means? Many hydrogen ions. Polyprotic acids would include sulfuric acid, phosphoric acid, bromic acid, and carbonic acid. How many hydrogens do they have? One or more than one? Do they have one or more than one, guys? More than one. So is that mono or is that poly? That's polyprotic. Okay. So once again, monoprotic is where you only have one hydrogen in the acid's formula. Polyprotic simply means you have an acid where there's two or more hydrogens in the acid's formula. Now to finish off today's class, this is hopefully going to be a review and nothing new. Naming acids. This is going to be pretty important. Okay, so there's two different ways in which you can name an acid, and what you have to do is you must identify the other ion. You're like, what do you mean identify the other ion? Well, take a look at HF. You see that hydrogen, right? Because there's a hydrogen, what should that just scream at you? Acid, 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 acid. That's an acid. This means it is an acid. That's a hydrogen ion. But this guy, this is that other ion. This is fluoride. Is fluoride monatomic, which means it's only one atom making up the ion, or is it polyatomic, which means there are multiple atoms making up the ion? It is monatomic. This is very important. Fluoride is monatomic. This literally means one atom. I need to tell you the rules for naming a monatomic acid. Other monatomic acids would be HCl, HBr, anything where the other ion, the anion, the second ion, is just by itself. It's just one. So the first thing you do, step one, you add the prefix hydro. You start off the word with hydro. Number two, you keep the root of the anion. In this case, we have fluorine. The root is fluor, F-L-U-O-R. Step 4, end the name with the suffix IC. So far, you're going to have why did I put 4? Excuse me, 3. You have hydrofluoric. In step 4, the second word is acid. Hydrofluoric acid. That is how you name monatomic ions, or monatomic acids. So I'm going to give you one to finish out today's class. I'll have to teach you polyatomic tomorrow. See if you guys can name this. You ready? What do I want to do? Okay. Can you name them? Give it a shot. Go with the rules I taught you. Just practicing right now. Are you going to name it, Kevin? Or are you asking a question?
I'll try.
Well, give everyone a chance to try to put it together.
Are these rules just for monoprotic?
Monatomic, not monoprotic. Okay. So you see an H there. You actually see 3 of them because it just screams acid, acid, acid. What is the anion in this case? What element is that? That's phosphorus. Now, if I look at phosphorus on the periodic table, it's found in group 15. What is its charge? -3. That is why there are 3 hydrogens there. Now, is phosphorus just one atom or is it multiple atoms? One. So you're going to use the rules for a monatomic acid. What should the name begin with? Hydro. What is the root of phosphorus? What do you think? Phosphor. And what do you end it with? Ic. And what's the second word? Acid. Hydrophosphoric acid. That is correct. Tomorrow I'll teach you polyatomic. Should take less than 10 minutes. You have homework tonight on conjugate acid-base pairs. It's what we did for about 80% of the class today. If you need to look up the video on YouTube, please do so. But just by judging, hold on, sit down. I really do think that a lot of you will be very well served by just staring at that, and you will do fine. See you tomorrow. Yeah.